Hello everyone, welcome to the series on chapter 1 of CBSE class 11 maths sets. In this video, we are going to discuss about exercise 1.2 problem solutions. There are a total of 6 problems in this exercise and we will solve every one of them. To solve this problem, you need to know 3 main concepts. They are empty sets, finite and infinite sets, and finally equal sets. These 3 concepts are explained in another video, the link of which is in the description. My name is Tejesh Kaliki from 2Pi Academy. Now let's get started. So we'll start with the first problem. Which of the following are examples of null set? So here null set is also called as an empty set and it is a set that has no elements. So if it has no elements in that, then it is an empty set or null set. First of all, we have the set of odd numbers divisible by 2. So what are the odd numbers? You can list them like 1, 3, 5, 7 and so on, right? And here, are any of these numbers divisible by 2? No, right? So therefore, odd numbers are not divisible by 2. So therefore, you can say that this is a empty set. Clear, right? There are no odd numbers that are divisible by 2. So therefore, this is an empty set. You can either denote that by this symbol or you can use the Greek letter phi. Both of these are representations of the empty set. Now the second one, the set of even prime numbers. So you all know prime numbers, right? They are 2, 3, 5, 7, 11 and so on. Now out of these, the only even prime number is 2. So therefore the set of even prime numbers has a single element, that is 2. Now an empty set has no elements, right? But this one has a single element. So therefore this is called as a singleton set. So clearly this is not an empty set. So this is it. Now the third problem. The set of all x such that x is a natural number and x is less than 5 and x is greater than 7. So to solve this, let us consider a number line like the following. So here somewhere in the middle we have 5 like this, and here we will have the number 7. Now the first, they are telling x is less than 5. So clearly x will be in this region. And in the second part, they are telling x is greater than 7. So x will be in this region. Now if you take any point on the number line, can this be in both of these sides at the same time? No, right? Both of these at the same time is not possible. So therefore this is an empty set, which means it can have no elements in that. So you can denote that by either empty curly braces or the Greek letter phi. And here we'll write that down. Therefore this is a null set. So the third set is a null set or empty set. Now let us move on to the last one, that is the fourth one. The set of y such that y is a point common to any two parallel lines. So consider any two parallel lines like the following. Now will these lines intersect each other? No, right? Parallel lines does not intersect. So therefore this is a null set. So to answer our given problem, that which of the following are null sets, they are clearly the first set, third set and the fourth set. 3 of these are null sets and the second one is not a null set. So this is the solution for this problem. Now let us move on to the second problem in this exercise. So the second problem is, which of the following sets are finite or infinite? You need to find which of these are finite and which are infinite. But what does finite and infinite sets mean? A finite set has a definite number of elements. Otherwise, it is called an infinite set. Let us try to understand that. First, the set of months of a year. How many months are there in a year? In every year, there are clearly 12 months, right? Clearly, there are some different calendars like some Indian calendar or something, but generally, worldwide, they will follow an year has 12 months, January, February, March, and so on until December, right? So here clearly 12 is a definite number, right? There are definitely 12 number of months in a year. So therefore, you can say that this is a finite set. There are exactly 12 months in a year, so therefore this is a finite set. Now the second one, we have the set of 1, 2, 3 and so on. Now when we end with this symbol, it means that the similar pattern continues and so on until infinity. So how many elements will be in this? Infinite elements. So if it has infinite elements, is it a definite number? No, right? It is not a definite number. So therefore this is a infinite set. It's clear, right? And now the third problem. We have 1, 2, 3 and so on up to here. This is the same as the previous one. But here we ended with 9900. So it means that you will continue and so on until we reach the element 100. So therefore, these are clearly first 100 natural numbers. So it will have 100 elements in that. So is it a definite number? Of course it is, right? 100 elements is a definite number. So therefore, this is a finite set. This is how we distinguish between finite and infinite set. If it has a definite number of elements, it is finite. Otherwise, it is infinite. It is clear, right? The set of positive integers greater than 100. So what are the positive integers greater than 100? First we have 101, and then we have 102, and then 103, and in a similar way it will go on until infinity, right? This does not end anywhere. You can keep on going that way, 104, 105, 106 and so on. So clearly this has infinite elements in this. So if it has infinite elements, which set it is? It is not a definite number. So therefore this is an infinite set. Clear, right? Another final problem. The set of prime numbers less than 99. So what are the prime numbers? They are clearly 2, 3, 5, 7, and here they said less than 99, right? The large prime number that is less than 99 is 97. If you want, you can check that out. Here clearly this ended here, right? So this means that there are definite number of elements. In fact, if you count them, you will get exactly 25 elements in that. If you want, you can list all of these and count them. You'll get 25 elements. So therefore, it has a definite number of elements. So which set it is? If it has definite number of elements, it is a finite set. So therefore, this is a finite set. So out of this, the first set, third set, and the fifth set are finite. The second as well as fourth sets are infinite. It is clear, right? Now let us move on to the third problem in this exercise. State which of the following set is finite or infinite. So clearly this is the same as previous problem. We need to find whether a set is finite or infinite. The same concept as before. So let us try to solve this. The first one, the set of lines which are parallel to x-axis. So to understand this, let us first draw a coordinate axis like the following. So here this is the x-axis and this is the y-axis. So now we need to draw lines that are parallel to x-axis. So we have one line here, and then you can draw another here and another, and in the bottom also you can draw like this. Now clearly you can move the line slightly a little and it will form a new line, right? So how many lines will be parallel to the x-axis? There will clearly be infinite such lines, right? So how many elements are there in this? There are infinite elements. So previously you have learned, right? If it has infinite elements, what sort of set it is? It is an infinite set. So that is it. We have counted the number of lines that are parallel to x-axis and you have realized that there are infinite such lines. So therefore it is an infinite set. And then the set of letters in the English alphabet. So if you ask a small child what are English alphabet, he will say A, B, C, D. There is some song by which they learn this. So through that song, they will tell all the alphabets from A to Z, right? So how many alphabet are there? How many letters are there in English alphabet? The same child will tell there are 26 letters in English alphabet. So therefore, this set has 26 elements, right? There are 26 alphabets, so therefore 26 elements. So is this a definite number? Of course it is, right? This is a definite number of elements. So therefore you can say that this is a finite set. As for the reason, it is clear, right? There are 26 alphabets, so therefore it has a definite number of elements, hence it is a finite set. When writing an exam, be sure to list the condition or why this is the case. So here there are 26 alphabet, which means 26 elements, hence it is a finite set, definite number. Now the third one, the set of numbers which are multiple of 5. So what are the numbers that are multiple by 5? So in the positive side, we have 5, 10, 15. This goes on until infinity. So clearly just the positive multiples themselves are infinity, but in a similar way, you can have 0 and you can continue in the negative side. Minus 5 is also a multiple of 5. And then we have minus 10, minus 15, like this. And even in the negative side, it goes on until infinity. So even the positive themselves are infinity and we are combining the negative as well. So therefore, there are double as much as infinity. Obviously there is no double infinity, so these are also infinite elements. This set has infinite elements in total. So which set it is? It is an infinite set. This is clear, right? The multiples of 5 can be infinitely many, hence it is an infinite set. Now there are some more subproblems in this. Let's try to solve them. The fourth one, the set of animals living on the earth. Now on the earth, how many animals are living? If you ask this any human, they say that counting is very difficult, right? Any human can't exactly count them, but the point is that this will have a definite number, right? At any point, if you count all the animals living on earth, you will have a definite number. So this will be very large number in billions, or it can also be trillions, right? So technically humans will not be able to count them, but the point is that it is a definite number, right? You can get a specific number of animals that are living on earth. So since it is a definite number, this is considered a finite set. So problems such as this are a bit tricky, so you have to answer them with caution. Now the last one, the set of circles passing through the origin 0, 0. So for this, let's draw the coordinate plane like the following. So origin is the point right here, 0, 0. Now you have to draw circles that pass through this origin, right? You can draw a circle like this, and you can draw a circle like this, and then like this. So the point is that you can slightly change the angle of the circle and you will get a new circle that passes through the origin. So clearly there are infinite such circles. So therefore there are infinite elements, right? You can get infinite circles such as this. So clearly this is an infinite set. It is clear, right? You can draw infinite number of circles that pass through the origin. So therefore it is an infinite set. So this is how you have to solve problems related to finite and infinite sets. Now let us move on to the fourth problem in this exercise. In the following, state whether A is equal to B or not. So here equal to refers to equal sets, which are sets with exactly same elements. Otherwise they are unequal sets. So here exactly same elements does not mean just the number of elements. It means the elements themselves should also be the exactly same. So let us try to understand with this problem. So here we have the set A and B. So A has the elements A, B, C, D, and B has the elements D, C, B, A. So we have to compare the elements in this. So first set has A and the second set also has A, and the first set has B and the second set also has B, and the first set has C and the second set also has C, and finally both of these sets have D as well. So you have to remember that in the sets the order of the elements does not matter. So you won't need to compare the order. You just have to check the elements. So clearly every element in A is in B and every element in B is in A, right? So in such cases we will say A and B are equal sets. So if A and B are equal sets, you can write A is equal to B. This is the notation for denoting equal sets. So in the problem they have asked state whether A is equal to B or not, and we have stated that. So this is how you have to solve this problem. Now the second one, capital A has the elements 4, 8, 12, 16. We'll compare it with the elements in B. So element A has 4 and element B also has 4, and the element A has 8 and element B also has 8. But here there is element 12 which is not in set B. So at this point you can directly quit and you can say A and B are unequal sets. But let us compare the other elements for formality. So here we have the element 16 and the second set also has 16, and the second set has 18 which is not in the first set. So one element in the first set is not in second set and one element in the second set is not in first set. So you can say A comma B are unequal sets. So what does it mean? You will write A is not equal to B. This is same as in numbers. Equal to means they are equal sets, not equal to means they are unequal sets. So the third one, capital A is the set of 2, 4, 6, 8, 10, and capital B is the set of all x such that x is a positive even integer and x is less than or equal to 10. So positive even integers start with the number 2 and then we have 4, 6, 8, and it is less than or equal to 10. So you can include 10 as well. So this is the roster form representation of the set. In case you don't know, in the roster form, you will list the elements separated by commas in enclosed in curly braces. We have been using that previously, right? All these are in roster form. So therefore, you have to write this in the roster form, which gives 2, 4, 6, 8, and 10. Clearly, all of these are same elements in A, right? 2, 4, 6, 8, 10. So clearly, A is equal to B. Both of these are equal sets. And finally, capital A is the set of all x such that x is a multiple of 10. And second one is capital B is equal to the set of 10, 15, 20, 25, 30, and so on. So first we have to write A in roster form, same as before. So in the roster form, you will list the elements in curly braces separated by commas. First we have the 10, which is a multiple of 10. And then we have 20, which is also a multiple of 10. And then 30. And you can continue and so on until infinity, right? Now we'll compare the elements. Set A has 10 and set B also has 10. And set A has 20, set B also has 20. And set A has 30, set B also has 30. So at this point, some people might do a mistake. Here, every element in A is in B, right? So clearly they are equal. Please don't do that mistake, because here set B has the element 15. Is 15 anywhere in set A? No, right? There is no 15 in this. And then there is 25. Is 25 in this? Clearly no. So all the elements of B are not in A. Some of them are missing in set A. So you can't say that they are exactly same elements. Hence, A is not equal to B. They are unequal sets, not equal. So this is the fourth problem. Now let us move on to the fifth problem in this exercise. Are the following pair of sets equal? Give reasons. So this is also same as previous. It is related to equal sets, means set which has exactly same elements. But here we have to provide a specific reason. So the first one, capital A is the set of 2 and 3 and capital B is the set of all x such that x is a solution of x square plus 5x plus 6 is equal to 0. This is a quadratic equation. X square plus 5x plus 6 is equal to 0. So to solve this, you can use the factorization method. So here we have 5. We need to find two numbers such that their sum is equal to 5 and their product is equal to 6. We have to find two such numbers. So clearly 2 plus 3 is equal to 5 and 2 into 3 is also 5. So these are the two numbers. Using that, you will split the middle element. In case you don't know factorization method, this is how you do it. X squared plus 2x, and here we have to write plus 3x. We split that into two parts, 2 and 3, based on this. Plus 6 is equal to 0. So in the first part, it will be x into x square is nothing but x into x. So therefore, you can take 1x from that, which leaves us with x. And here we have 2x. By taking out x, you will have 2 remaining. And in the second part, you have to take 3 as common, which gives us 3 into x plus 2 is equal to 0. And here we can take x plus 2 common from both of these terms, which gives us x plus 2 into x plus 3 is equal to 0. So what will be the values of x? X can either be minus 2 or it can be minus 3. So these are the elements of the set. Capital B is equal to the set of minus 2 comma minus 3. We have listed the set in the roster form. Now we have to compare the elements. Here there is 2, but here there is no 2. And here there is 3, and here also there is no 3. These are both negative of this. So therefore, they both does not have exactly same elements. So therefore, they are unequal sets. So you will say A is not equal to B. As for the reason, we have solved this equation and we got x is equal to minus 2 and 3. So this is the roster form of the set. And you compare the elements. So that is the reason why these are both not equal. Now let us see the second problem. Capital A is equal to the set of all x such that x is a letter of the word follow. So we will first list this in the roster form. So you have to list the elements in curly braces separated by commas. So first here we have the letter F. So you can write down that. And then the letter O. And then the letter L. One thing to remember in sets is that you should not repeat elements. The elements of the set must be distinct. So here there is another L which is repeated, so you won't write that, and O is also repeated, and you will finally have the letter W. So this is the set capital A. And then we have the set capital B. Capital B is the set of all Y such that Y is a letter in the word wolf. So clearly wolf does not have any repeated letters. So you can directly list all these elements. So capital B will be the set of W, O, L, F. This is the set capital B. So we'll compare the elements. First set has F and the second set has F. First set has O and the second set has O. First set has L and the second set also has L. And finally, both of these have W. So what does that mean? They have exactly same elements. Hence, you can write capital A is equal to capital B. They are equal sets. For the following pair of sets, equal is a question and the first set is not equal and the second set is equal. That is the answer. As for the reasons, first set you solved that and you got x as -2 and -3, which made us write that in the roster form and we compared the elements. And the second one, you just wrote the roster forms for both of these and compared the elements. That is how you solve this problem. Now let us move on to the last problem in this. From the sets given below, select equal sets. So clearly this is also based on equal sets, the same concept. The sets with exactly same elements are equal. So here we have to compare every one of these sets. For this there is some simple trick you can do. So here the first 4 sets has 4 elements each, whereas the other 4 sets has 2 elements each. And sets cannot have repeated elements, and you can clearly check that there are no repeated elements in any of these sets, right? So therefore there is no need to compare the sets in the first row and the sets in the second row, right? Even the number of elements is different, how will the elements be the same? So we will first compare the first 4 of the sets and then the next 4 of the sets. So first, set A has the elements 2, 4, 8 and 12. We will compare that with set B. Set A has 2 and set B also has that, and 4 is also in both of the sets, but 8 and 12 are not in set B. So they are not equal. In fact, you can write down here A is not equal to B. They are unequal sets. And then we will compare A and C. So A has 4, C also has 4, A has 8, C also has 8, and A has 12, and C also has 12. But here it is broken at 14. There is no 14 in A, and clearly 2 is also not in C. So therefore you can say A is not equal to C. And then you will compare A and D. A has the elements 2 and D also has 2, and A has 4, D also has 4. But then 8 and 12 are not in D, and 3 and 1 are also not in A. So once again, A is not equal to D. And clearly you don't have to compare A with these 4, right? As we have said, they have only 2 elements, so they can't be equal. So this is where we will stop. Now we will compare it with set B. Set B has the elements 1, 2, 3, 4. Comparing it with set C. So the elements 1, 2, 3 are missing in C, right? So therefore clearly B is also not equal to C. If you want, you don't have to list all these unequal sets because they have just asked you to select the equal sets, but we can just list them for formality, right? And then we'll compare B and D. B has the elements 1 and D also has it, and then B has 2, D also has 2, and then similarly we have 3 and 4 in both of these sets. So clearly they have exactly same elements, so therefore B is equal to D. So we were asked to select equal sets, so clearly B and D are equal sets. So we have selected the equal sets. Now let us see C and D. Note that you don't have to compare C with A and B, right? Clearly A is not equal to C and B is also not equal to C. So we'll compare C and D. So you can just search for elements that are not common in them. So here 12 is not common in them, right? So that is directly a deal breaker. So you can directly say C is not equal to D. So out of the first rows, only B is equal to D. Now let us move on to the second row. So here we have capital E with the elements -1 and 1. You can compare that with F, and clearly -1 and 1 are both not in F. So you can say E is not equal to F. And then the set A has element -1, which is also in set G, and set E also has 1 and set G also has 1. So they have exactly same element. So therefore E is equal to G. So this is another pair of equal sets. If you want, as they have asked, you can circle them. You have selected the equal sets. So now E and H. E has the element -1 and 1. H has 1 but -1 is not in this, and 0 also not in E. So E is not equal to H. So it is done. Now we will compare it with set F. Clearly you don't have to compare it with E because it's already done. And then F and G you can compare to get F has the element 0 and A. G not have both of them, so therefore F is also not equal to G. And then you will compare F and H. 0 is in both of these sets, but set H has 1 which is not in F, and set F has A which is not in H. So F is not equal to H. Now finally we just have to compare G and H. But you might ask, sir, clearly E is equal to G and E is not equal to H. So doesn't that mean G is also not equal to H? Of course, both of these are equal and one of them is not equal to some another set. So you can clearly say that G is also not equal to H. But let's just compare the elements for some formality purpose. So G has the elements 1 which is also in H, but G has minus 1 which is not in H, and 0 is also not in G. So clearly G is not equal to H. So clearly the solution of this problem is just B is equal to D and E is equal to G. Both of these are the equal sets among these. So this is the final problem in exercise 1.2. So we have solved all the problems in 1.2. Thanks for watching the video. If this video is helpful, please like the video and subscribe to the channel to not miss any future uploads. See you guys in the next video.